Alright, so welcome to another video. Today we are going to look at the exceptions or the limitations of solving integration by parts, of course, using the tabular method. So, the tabular method makes work so swift, but it has so many limitations, of which we are going to look at them right here. So, these are the functions that are unsuitable for the tabular method. Of course, you know that when you have len x, you can never differentiate it to a constant. So when you want to integrate len x, you cannot use the tabular method. And when you have a cyclic function, of course, this is what I mean. One, when you have a function like this, a function that contains len or logarithmic functions, you cannot use the tabular method to approach it. Two, when you have a function like this, an exponential function and a cyclic function. This is a cyclic function. Of course, when you integrate sine x, you have negative cos x. When you integrate again, you have negative sine x, right? Of course, it keeps on. So we call it cyclic, right? So, of course, when you keep on integrating, you keep on having sine s, cos s, sine s, cos x. So a function that have in this form, we don't use the tabular method. 3, our third function is, of course, when you have e power x cos x. Of course, this also forms cos x, also is part of the cyclic functions, because when you integrate cos x, you're going to have sine x. Integrate again, you're going to have negative cos x. It follows in that pattern, right? So when you have sine, cos combined with an exponential function, you don't use the tabular method. And of course, we have other ones where you have, say, integral. So this is 3. The fourth one is going to be x into cos into s squared dx, right? So this function, for instance, when you want to integrate cos, right, you cannot cos into s squared, right, will be non-elementary, right? You know that when you integrate cos into s squared, is going to be sine into s squared, right, all over 2x, right? That is how it's going to be. So this is non-elementary. So when you have a function like this, you don't attempt to use the tabular approach, right? Now let's look at the fifth function that you cannot apply the tabular approach. The fifth function is, of course, any function or an exponential function that comes with the len, right, or a logarithmic function. So right here, which one are you choosing for u and which one are you choosing for v? So you cannot use the tabular approach to, solve this kind of problem, because when you choose len x, of course you are going to choose len x as your u, and you cannot differentiate len x to a constant, right? So this is our first function that you cannot use the tabular approach to handle it. The seventh function is going to be when you have x e power s squared dx. right? This is also part of the non-elementary functions. So you don't attempt to use the tabular approach, right? And then we have the seventh function, of course, is sine and then ln x. So when you have sine x and ln x coming together, don't attempt to use the tabular method to tackle this kind problem. Because of course, you cannot choose sine x as your u, and you're going to definitely choose ln x as your u. And you cannot differentiate ln x to a constant. That is it. We have, two more to go. Two more to go. All right. Let me handle it here. So the eighth function that you cannot apply the tabular approach is a function of this form, s power n, then you have e power negative s squared dx, right? So when you have a function like this, you cannot apply the tabular approach to handle a function of this form, right? So you know that n here is any number, any real number, right? So from any natural number, right? So and then you cannot choose this as your u. Of course, you're going to choose this as your u. But in this case, this right here is non-elementary. What I mean by non-elementary is that when you integrate this, you're going to have e power negative s squared over negative 2x. Of course, you are not having a complete elimination of the variable from the function, right? That is what we call non-elementary. And then when you go again, you're going to have e power negative s squared over 4 um over 4s squared, right? It keeps on going. So you cannot go away with the variable in the function, right? So the next, that is the final function, is going to be a function, right? Any expression combined with the ln, right? So when you have a function like this, ln into s squared plus 1 dx, you don't attempt to use tabular approach to handle a function like this, because of course you are going to choose this as your u, and nothing, of course you cannot differentiate this to a constant, because anything inside here you are going to use a differentiation to approach it, and you cannot do that to a constant. So this, you cannot handle it using the tabular approach. This kind of function, you cannot use the tabular approach. This kind of function as well, this, 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 and that. So study the functions well, so that when you have any function of this form, you don't attempt to use the tabular approach. The tabular approach is solely applicable to functions that are repeated, all right, that we have a repeated application. So for instance, when you have s squared e power x, right, this is what I mean by repeated application. So when you have x doubled, right, that is when most times the tabular approach is applicable. You see, we have e power x, not e power x squared, right? So this case, when you integrate this, you are going to have e power x over 1, right? Not over 2x or something. You understand? So that is how we apply the tabular approach, and these are the exceptions. All right. So thank you very much for watching. I really appreciate your time. If you really enjoyed this lesson, don't forget to press on the notification bell, subscribe, and then I'll give you more updates. Bye-bye.